experiment, our aim is to consider a suitable dataset for which we have taken a speech given by one of the ministers. Then we are going to remove the stop words. We are going to apply stemming and feature selection techniques to represent the documents as vector, and classify the documents and evaluate the precision. So what are the stop words? So in computing, stop words are the words which are filtered out before or after processing of natural language data. Though stop words usually refer to the most common words in a language, there is no single universal list of stop words used by all natural language processing tools. And indeed, not all tools even use such a list. Some tools specifically avoid removing these stop words to support phrase search. Any group of words can be chosen as to be stop words for a given purpose. For each search engine, there are some of the common short words such as the, is, at, which, and, on, etc. In this case, stop words can cause problems when searching for phrase that includes them, particularly in names such as the, who, the, or that, take. Other search engines remove some of the most common words, including lexical words such as want, from a query in order to improve performance. For an example, we use the NLTK tokenizer, wherein NLTK represents Natural Language Toolkit library, and from the tokenizer we import sent tokenize and word tokenize. Then also from there we import the stop words. Now, our data is a variable that we declare and store a string. Then the stop word is again another variable to which we set the stop word dot words English, wherein we said that the input would be in the English format. The words we use the tokenizer function and store the string variable that we declared over here into this and create a list. Then using the for loop we iterate through every word in this tokenizer, and if the word is not in stop words, word dot filtered will get appended with that word. That is, we will append in this list that word if that word is not present in the stop words, and in the end we print the list. Now for stemming is the process of reducing inflected words to their word stem, base or root form, generally a written word form. The stem need not be identical to the more morphological root of the word. It is usually sufficient that related words map to the same stem, even if this stem is not in itself a valid root. Algorithms of stemming have been studied in computer science since 1960. Many search engines treat words with the same stem as synonym as a kind of query expression, a process called as conflation. A suffix stripping algorithm is famous for stemming. A stemming is basically wherein we use of a root word, in this case Python, to find whether or not the given word is related to it, such as Pythonian, Pythoning, Python, and Pythonly, wherein in all these four cases the Python turns out to be the root word or the stem word, and with certain suffix attached to that word we get these other words. So stemming is used to find the root word from a huge sentences or a single words. Now suffix stripping algorithms, they do not rely on a lookup table that consists of inflected forms and root forms relation. Instead, typically small list of roots is stored which provides a path for the algorithm given an input word form to find its root form. Some examples of the rules include: if the word ends in ed, remove the ed; if the word ends in ing, remove the ing; and if the word ends in ly, remove the ly. Suffix stripping approaches enjoy the benefit of being much simpler to maintain than brute force algorithms, assuming the maintainer is sufficiently knowledgeable in challenges of linguistics and morphology and encoding suffix stripping rules. Suffix stripping algorithms are sometimes regarded as crude given the poor performance when dealing with exceptional relations like ran and run. The solution produced by suffix stripping algorithms are limited to those lexical categories which have well-known suffixes, with few exceptions. The feature extraction. In machine learning and statistics, selection, also known as variable selection attribute selection or variable subset selection, is a process of selecting a subset of relevant features for use in model construction. The following three are the points which I'm going to use. First is the feature selection techniques that are used for four reasons. The first being simplification of model to make them easier to interpret by researchers, shorter training times, the third one being to avoid the curse of dimensionality, and the fourth one being enhanced generalized by reducing overfitting. So this is a flowchart that shows the flow of the program while we are doing it. Firstly, we use a raw text, then we use sentence segmentation on that raw text and form list of strings. Then using the tokenization, we create a list of strings that are tokenized. Then the part of the speech tagging is done, wherein the entity detection is done, and at last the relationship detection is done. So let's see the program that we are going to use. So this is the paragraph, which is one of the speech given by one of the politicians that we are going to use over here. And if you have not downloaded NLTK, you can use this command to download it. Then further, after downloading, we import the NLTK, and from that we download the PUNKT. Further, using the sentences variable, we store the NLTK.send tokenizer, the paragraph that is the speech that we have taken. We give it or provide it to the function which is send tokenize, which is a part of the NLTK library. Now the sentences that are stored in the sentences variable are over here, which is the every full stop a sentence is created and it has been stored in the form of a string into the list. Now further, we use the tokenizer to tokenize this every sentence and store it into the words, and we can have it that the every single word is taken over here, wherein over here we took the entire sentence. Now the NLTK stop words, it is downloaded from the NLTK library. Then we also import this stop words after downloading it and use it to tell that the words are in the English format. And using the predefined, some of the predefined stop words, it checks whether or not and which all words in our paragraph are stop words, and form a list of stop words which we have printed over here. And we can see that it has removed each and every stop word that is present into our paragraph. Now further, using the Porter stemmer function, we store it to a stemmer, or we use a variable to represent or an object to represent that function. Further over here, we use that function or the variable which stores this function to find the stem word over here from the word. And the word, now further, from the NLTK we download the WordNet, we import the WordNet lemonizer and take an input string which is an example string. We provide it to the function, and using the word in the input this, that is, we represent a variable for every word in this. We use the operation lemonizer.lemonize word, and this is the input or the output that we get after giving the input. That is all for the program.